Hello, let's talk about what can be done to change how fast something dissolves. Basically, the rate of solvation or dissolution, dissolving, how we make things dissolve faster or slower. Well, this is based on the idea of the collision theory, essentially that things must interact by colliding. So in order to dissolve, the solvent particles must collide with the solute particles. If the bond between the solute and solvent is greater than the bonds between the solute particles, dissolving will occur. If you can overcome the bonds between solute particles and pull them apart, the object will dissolve. Since this only happens through collisions, basically to change the rate of dissolution, to change how fast something dissolves, we need to change the number of collisions that happen. More collisions means faster dissolving. Less collisions, less dissolving. One of the common ways to do this would be through temperature. Let's say we're talking about dissolving some tea into water. On the left of the picture here, I have a glass of cold water. And on the right, we have hot water. As you can easily tell, the right-hand side is dissolving more and dissolving faster. And you should know this from your common everyday experience. If you want to dissolve faster, tea dissolves faster in hot water than it does in cold water. Temperature and the rate of dissolution, or how fast it dissolves, is a direct relationship. Because the solvent particles move faster, they will collide more often and therefore dissolve the solute faster. Temperature, though, does have another effect. It does also change solubility depending on what's being dissolved. I talk about that in a different video under solubility charts, but essentially temperature can affect both solubility and how fast it dissolves. Another way to make things dissolve faster or slower is by changing the particle size, by changing the surface area. Again, let's go back to that idea of tea. If you want to dissolve sugar into tea, which would dissolve faster? A sugar cube or a packet of sugar? Well, the packet of sugar dissolves faster because it's got smaller particles. It's got a larger surface area. That means surface area and rate are direct relationship. More areas, more contact places means faster dissolving. When you open up more places to collide, you get a faster rate of dissolving. The bigger the particle, the smaller the surface area, and therefore the slower the rate, so particle size and rate are inverse. You want something to dissolve faster, you grind it up first. Same rule basically as reacting. And the last way is basically through agitation. It's common sense. You want to dissolve something faster into a solution, say again, sugar into tea. You might want to stir it or shake it. The more collisions that happen, the faster it dissolves. With stirring and shaking by agitation, you are causing the motion to increase. You're causing more collisions to happen. And therefore, you're causing a faster rate of dissolution. So temperature, surface area, and agitation can change the rate of dissolution. Pressure, on the other hand, does affect the solubility of gases. If we have a higher pressure on gases, more will dissolve, but it doesn't affect how fast it will dissolve. So although temperature affects solubility and how fast it dissolves, pressure just affects solubility. So don't get caught up on that. Don't get tricked by that.